Greetings, parasite ecologists. I left you in the last installment about monogenes' host specificity. In this video, we're going to talk about what hosts the monogenes infect and how they track those hosts. We're also going to talk about what it means to be a hyperparasite, but more on that in a moment. Now, the monogenes can infect lots of different vertebrate hosts. Most monogenes use fish. Bony fishes primarily, but we also sometimes find them on the cartilaginous fishes, the sharks and the rays. We can also find them in the cloacas and on the eyeballs of amphibians. They can be found on marine cephalopods. There are a few in reptiles, and there is one species of monogene that infects the eyeballs of hippos. But you don't have to be a vertebrate to be infected by a monogene. There are actually also several species of monogenes that are hyperparasites. This is the monogene genus Udonella, which is a hyperparasitic monogene. Hyperparasite is a parasite of a parasite. The diagram that you're seeing here is of a parasitic copepod. We're going to learn about the parasitic copepods when we get to the arthropod section later on, but suffice it to say for now, this is a parasitic copepod that lives on the gills of marine fishes. Udonella is a hyperparasite, meaning it is parasitic on this parasite. You can see that it's stuck onto the egg capsules of this copepod in the lower right-hand corner of this diagram. I want to show you some pictures so that you can see what this looks like in real life. Here you can see the Udonella adult attached to the posterior portion of this copepod, and then in the circle, an Udonella egg. So this adult Udonella has done its copepod host the favor of laying its eggs right there on the host. The adult Udonella exists alongside the clutch of eggs that it has just laid. Here's what some adults look like attached to the egg sac of this parasitic copepod. So the egg sac is along the lower portion of the image, and then all those guys stuck onto the egg sac are monogene adults. And here are some Udonella adults laying their eggs en masse on a copepod parasite. So here's our hyperparasite, our parasite of a parasite. Whether you're a monogene parasite of a vertebrate host or a monogene hyperparasite of an invertebrate host, your life cycle is largely the same. You start out as an egg. This is what it looks like when these monogenes are laying their eggs. Here the eggs are emerging out of a genital pore, and they can either be laid directly onto the host, as we saw Udonella do on its copepod host, or the eggs can be released into the water column. This is what the eggs look like once they're released. They each have one little filament, and often that filament is designed to be sticky, so that these eggs wind up snagging on the benthos or maybe even on a passing host. Once released, those eggs hatch, and out pops a tiny ciliated larval stage called an onchomycetium. This is the stage that is infectious to another host. It can swim, but it isn't very strong, so it really depends on luck to intersect with a host of the right species. But once it does, it can settle down, mature, mate, and produce eggs of its own. Here's what that little onchomycetium looks like. Basically a shrunken version of the adult, but it is ciliated, so it can move through the water column, whereas the adult is not swimming at all. It is attached to its host. Even though this diagram looks like a complex life cycle because it has a lot of steps, this is actually direct transmission because the parasite has only one host species. It is moving from a fish to another fish of the same species, and it doesn't require any other host species for the completion of its life cycle. It can get along just fine with access to just one host species. Now, for a brief interlude. I want to talk for just a moment about how the location that a parasite chooses to infect can impose some constraints. In some ways, the monogenes are super smart. They're ectoparasites, meaning that they live on the external surface of their host, skin, gills. In contrast, we have the endoparasites, who live inside the host body. Now, we can further define endoparasites into superficial endoparasites, which are parasites located in some sort of internal body cavity that has a direct connection to the external environment. Think about the gut, which is connected to the external environment through the mouth and the anus. Or the lung, which is connected to the outside world through the bronchial tubes. Or the bladder, which is connected to the outside world by the urethra. Of course, all of these have analogs in other kind of vertebrates, but you get the drift. A superficial endoparasite is one that has an easy passage into the outside world. Then there are the somatic endoparasites, who make life really hard for themselves because they are located in an organ that doesn't have a direct connection to the external environment. Think inside the brain, in the blood, in the muscle, inside the body cavity. Remember, we've already come across flatworms that have the problem of being a somatic endoparasite. Remember the schistosomes, which are living in the circulatory system, but their eggs have to get into the outside world somehow. How much easier to be a superficial endoparasite, where you just shed your eggs and they'll be pooped and peed or coughed into the outside world. Or better yet, an ectoparasite, where your eggs can literally just be shed out of your own body, and then they immediately make it into the outside environment. In this way, the monogenes are pretty smart to pick an ectoparasitic lifestyle. Anyway, interlude over. Because they're so host-specific, the monogenes have gotten really, really good at tracking their hosts through time and through space. To show you an example of this, I want to introduce you to Polystoma integerarium, which is a monogene parasite that infects amphibians. In fact, Polystoma integerarium loves to live in frog cloacas. Now, amphibians aren't in water all the time, and that is a problem for monogenes because they need to release their eggs and their Onchomyricidia into an aquatic environment. They can't just dump them on the ground and expect them to be okay. Frogs are in the water for some period of their life cycle, but they're amphibians, right? It's not for their entire life cycle. I want to start in this life cycle diagram of Polystoma with the eggs in the upper right. Let's look at where that Onchomyricidium is infecting a newborn tadpole in an aquatic environment. The eggs hatch in the water, the Onchomyricidium is swimming through the water column, and then it enters the spiracle, or the opening to the gills, of one of these poor little tadpoles, and it becomes attached to the inner part of the tadpole's gills. As the tadpole metamorphoses into a frog and begins the terrestrial portion of its life, Polystoma migrates into the bladder, and that larva grows with the young frog and then just kind of stops. The monogene reaches this stasis period. It can feel that its host is in a terrestrial environment, and it knows there's no point in developing to sexual maturity right now because there's no reason to yet. My host is not yet in an aquatic environment. But as soon as spring rolls around and Polystoma senses the sex hormones that are cueing its own host to start its own cycle of breeding, this parasite says to itself, all right, time to kick into gear. The host's sex hormones stimulate maturity in the parasite, and so by the time the frog returns to the water to lay frog eggs, Polystoma is ready to lay its own eggs, and it does so in the host bladder so that they can be released into the water along with the frog's eggs. So the monogene eggs are released, they hatch, they go on to infect the new little tadpoles that are being born in that aquatic habitat. And now it gets even trickier. It might be amazing enough that Polystoma is able to read its own host's sex hormones and use those hormones as a cue for when to begin its own breeding cycle. But if they find themselves being released early in the breeding season, some of these Onchomyricidial larvae will actually attach onto the external gills of the tadpoles and begin a whole different life cycle that we call neoteny. Neoteny is the process where you become sexually reproductive even though you still look like a larva. So it's basically a way of short-circuiting the life cycle and amping up sexual reproduction in a larval parasite where no sexual reproduction is supposed to be taking place. Why? Well, it's a way of getting more reproductive bouts, more generations into a single breeding season, and therefore producing more offspring and maximizing your fitness. What happens is that the Onchomyricidial larva attacks the outer gills of the tadpole and then begins this lightning-fast development into what's called a neotenic larvae, which is a larva that can actually sexually reproduce. It then copulates, produces eggs, which yield Onchomyricidia, which will infect the internal gills and go along with the next amphibian on its full metamorphosis. Of course, this comes with trade-offs. If you're using neoteny, you're probably not going to be able to produce as many eggs as you might if you're a full-grown adult who's had the whole year to grow. Look at the size difference between a regular Polystoma adult and a neotenic Polystoma. The full-grown adult can produce a lot more eggs, and of course, if this parasite wants to survive the winter, it needs to accompany its host during the terrestrial part of its life cycle. But By using both reproductive pathways, the parasite ensures that it can squeeze a bunch of reproductive bouts into one season and still survive the winter. So this parasite is really finely tuned to the reproductive cycles of its own host, which allows it to take maximum advantage of every breeding season. One of the major advantages of being extremely host-specific is that you can get really, really good at infecting your host. And Polystoma is a great example of how parasites can evolve very finely tuned adaptations for tracking their host through its environment. This kind of tracking can only work if you know how to read your host like a book. For more monogenes, I'll see you in the next video.